Okay, hello YouTube, ladies and gents. We have a laptop today to fix. This is an Asus laptop. Um, the, it came in for charging port repair. The model number is X405U. Let me show you. Yeah, X405U. It came in for charging port repair, but life is not as easy as it is. So it's always something more than what the customers tell us. Okay, this laptop, I have already unscrewed it. I have taken the screws off just to save some time, and I have taken all the screws off actually. So I have already tested it for charging port. Charging port looks intact. I'll show you. Look, the charging port looks intact. And the pin is fine. This is all okay, no issues with that. But I'm gonna do my own testing on it as well. Let's see. Okay, my DC power supply is set to 19 volt and 5 amps, and I'm gonna put my multimeter into the voltage mode, DC voltage mode, and the first thing first, I'm going to check if this 19 volt adapter is giving me power, which is okay. Look, 18.965. Well, next thing I'm going to do is check if the voltage is coming through the charging port, and that's how you can test it. Let's see, and 18.96 is coming. Okay, so the charging port is okay. There's no issues with that. Okay, so DC voltage setting 19 volts coming through, no problems. Okay, next thing I'm going to check is if I have 3 volt present at the battery connectors. Okay, no. Okay, pin number. Okay, if I put it this way, then it's more visible, I believe so. Okay, the middle pins, 3 volt always is not present, so 3 volt is missing. So at the initial stage, the 3 volt is missing. 3 volt is the power that is the first voltage created to run the machine, run this circuitry, and it goes to battery pins, on and off switch, super IO, and some other places as well. So if we don't have 3 volt, then this won't power on. Okay, so next thing is I'm gonna remove this. I'm going to check for any physical issues on this one. So I'm going to use my microscope now. Okay, let's see, and microscope on. Have a microscope? No, no. Oh, it's off. Okay, let's power it on. Hopefully we get a microscope. Come on, microscope. For the physical examination, I'm going to check the charging port. That looks okay, and if there is any other damage to the areas, I will check that as well. That capacitor looks a bit touchy here. Anything else? Okay, right. Any other physical damage, little damage? I'm going through the board very quickly. Okay, I see something here. Okay, it's a fan. Okay, doesn't look bad really. It looks okay. Looks good. The back looks neat and clean, you know. The back side of the board is neat and clean. No issues with that. Super IO is okay. No physical damage except for the one capacitor that I've seen here. Okay, well, the problem with this board is it does not have any schematics or board view available for this board, so it's a bit of a problem, you know, when you don't have these kind of information. You always struggle to find where the problem is, or which IC or which section of the board is doing what. So that's a bit of a problem, but if you have been fixing board for some time, then you will have some idea, you know, that which IC is doing what. If you get a, you need to look for the clues um, that what the IC is and what the section of that IC alongside that IC, surrounded by that IC, is performing that action, you know, so you can guess, but it's always best to have the schematics. Okay, I see. Nothing really much damaged on this one. Okay, okay, well, let's see, you know, like how you go about fixing a laptop like this. So you have your own SOPs and you follow them, and you reach to the point where uh, any of the SOP fails, and this is where you look for the problem. Okay, okay, I have the charging port here. You change it. The charging port is here, and well, it's, and then there is, this is the ground. All this area is ground, so the charging port is going on the other side. Yep, here, right? Okay, this is the main rail, main power, and this is going through some of the inductors here, and there is a capacitor here, and there's also a capacitor here. So there's two capacitor, three coils, and then is going through these resistors, and this power plant goes here, and we have a current sensing resistor here also. Okay, but if you look at it, you know, this IC has is a Realtek IC, so most probably this IC is for sound, possibly, or WLAN. So it's not connected to the charging circuitry, so we will leave this area. We won't look into this, and we have a MOSFET here, and okay, this line from here goes here. Okay, let's see, this is the charging port section. If you look at it here, and three coils, two capacitors, two resistors, and there is some vias here, So this power is going to the other side of the board from here, and okay, we go on the other side, and we have a capacitor here. Let's see if we are getting 19 volts on this capacitor. Let's see how far the 19 volt is going first. Okay, we have change it to maybe the big one. No, that's not good. Microscope. Okay, I'll try and show you. Okay, so we know this is 19 volt, this is 19 volt DC range. 19 volt is coming. No, what happened? Oh, my multimeter is not synchronizing with the screen. What is that? Just 1 minute. Let's see if it does now. Oh, multimeter, come on, wake up. Okay, yes, 99. Oh yes, it's showing now. So if you look at the green numbers there, it's showing 19 volt is here. So we know that 19 volts through those 3 coils and 2 capacitors, 2 resistors is coming to this section here. Here it's coming in this section here. So we should have 19 volt on this capacitor somewhere. So that's ground, and come on, DC. Yes, we have 19 volt on this capacitor. Okay, after this I think this is the first MOSFET, and we will look into this here. So we have 19 volt here. Do we have 19 volt here? No. Okay, this is a MOSFET. So we have 19 volt on one side of the MOSFET, and the second side is not. And this is the gate supply. Let's see what's on the gate supply. There is nothing on the gate supply. Well, that's a problem. Okay, so 19 volt coming here. So our problem is we have 19 volt on this side of the MOSFET, but it's not transferring here, and from here it's supposed to go to this secondary MOSFET, and from here it should have something here. Let's see. Don't have anything here. No voltage. Any gate supply? No. This is the ground. So we know that 19 volt is stopping at the very first MOSFET here. This stops here. Okay. Another section. This is 19 volt. So this gate supply is coming from somewhere. So I need to trace this first, where this is coming from. Okay. So when I know about this, then I can resolve it. I can do something here also, but that won't be right. I could just bypass this gate and transfer 19 volt here, but you know, this gate supply is very important. We can't just miss it. We need to have something here. We must know why this is not generated. This is a switch. This is a power on and off switch for this MOSFET. So basically this switch is telling MOSFET to transfer this voltage to here, and this gate supply is connected through this capacitor here, and then we have a resistor here. Okay, let's look at the board a little bit more closely, and we'll see, maybe we can find where this power supply for the gate voltage is coming. I'm gonna switch to the bigger cam, and let's see if we can find out where we are. I'm just gonna zoom this a bit. Okay, that's enough. That's it. Okay, we have the board here. I'm gonna we came off. Let's see. With this board, so we have 19 volt present in uh, the first MOSFET, but second side of the MOSFET is not available. And okay, let's look for the clues. Okay, these two MOSFETs are driven by a charging IC, and charging IC is somewhere near the charging IC controls these two MOSFETs, and it controls the battery pins as well. It gives power to battery pin as well. So if we go towards, I don't find any IC that controls these two MOSFETs here. These two MOSFETs, I don't know if you can see that. Yeah, here. Okay. So yeah, these are the two MOSFETs that we have problem with. Okay, and the gate supply, we don't know where it's coming from. So we look for the clues. Okay. Right, okay, we have a battery connector here, and right next to it is this inductor, and we have one IC here. So this is probably the MOSFET for this inductor, and there is one IC here. Okay, let's check this IC. Let's check this IC, what this IC is doing. Okay, microscope. Right, okay, that's the battery connector, and we have inductor here. We have power current sensing resistor here also, and we have a, this is a MOSFET we have, and this is, if you look at it closely, you will see that this MOSFET is being controlled by this IC here. So I don't know if you could see that. Yes, you can actually, yeah. So we have a MOSFET here, and this is being controlled by this IC. Okay, we have something here. Let's see what's this. Okay, what number is this IC? I can see it actually. BQ24780S. Okay. Okay, let's check on the computer. BQ24780S. Okay, let's see what this IC is and what it does. Okay, we have a data sheet for this IC somewhere. Okay, Texas Instruments. Yes, that's what we needed. Pinout details. Okay. Right. What we want to find out with this IC is how the pins are behaving. Okay. Right, okay. Okay, this is why we are interested in AC drive. AC drive is the pin that will control those two MOSFETs. Okay. How do I know about that? Well, We can read this here as well. Charge pump output to drive both adapter input and channel MOSFET and reverse blocking and channel MOSFET. AC drive voltage is 6 volt above same as RC when AC OK is high. So well, this pin number 4 for this IC is controlling those two MOSFETs. So we need to find out if we have a problem with this IC. If there is a problem with this IC, obviously those two MOSFETs are not going to work. Okay, I don't know if you can. So the pins I'm interested in is pin number 28, which is VCC. This is the power coming to this IC. And okay, then we have ACN, pin number 1, AC OK, and AC detect. Okay, so number 28, 1, 5 and 6. Okay, we'll get back to this as well if you want to. Let's see. So if I go back to my microscope. Okay, so let's check this IC first.
So leaving this, I'll just book this out.
Okay, with this IC, pin number 28 is important for me. Okay, which is if this is pin number 1, 2, 3, 4, 5, 6, 7, 7, 14, 21, 28. So this is 28, pin number 28. So we should get something here. We don't get anything. Yes, this is pin number 28. Okay, this is the VCC. So we know that this IC is receiving 19 volts. So this IC has power coming into it. Let's see what other things we can check with this one is AC in number 1, pin number 1. Okay, pin number 1 is this. So we'll check this pin number 1, and this is, are we even interested in this one? Let's see. Okay, so we were testing this IC, and let's see. We know that pin number 28 has 19 volt coming. So this is pin number 1 all the way 7, and this side is 14, 21, and here it comes to pin number 28, the very last one. So this is pin number 28, 18 volt coming. And then I'm going to look for the other signal on this IC is AC detect. So AC detect on this IC is number 6. Okay, pin number 6 is AC detect. So it's 2, 4, 5, 6. AC detect is here, and we have 2.5 volt. That's okay. Okay, next thing I'm going to look is there any LDO 6 volt coming through this IC. So LDO 6 volt comes on which IC, which pin number it comes on. Let's see, the IC is 24. Pin number 24 is LDO 6. So 7, 14, 21, 22, 23, 24, 25, 26. I can't dig in, but just carefully get this number. Oh, I can't get to this one. AC detect pin number 24. This is pin number 24. 7, 14, 21, 22, 23, 22, 23, 24, 24. So we have 5.87. This is pin number 24. And next thing I'm going to look for AC OK. Let's see, AC OK in on this IC. AC OK is at pin number, so I'm just looking at the IC now in my computer screen. AC OK is pin number 5. Pin number 5. 1, 2, 3, 4, 5. Okay, so this IC is actually doing what it's supposed to do, so there is no issues like this. Is AC OK is a signal where it says the adapter current is okay. Okay, then I'm going to look for the next signal on this is AC drive. AC drive on, let's see. Okay, AC drive is pin number 4. Should get 24 volts here. Oh, sorry, can't see that. Okay, AC drive is pin number 4 and I should get about 24 volts here. So I don't get 24 volts. But this is the pin that is connected to those two MOSFETs that we looked at before. So AC drive, let's see if it is making a connection from here. I'm removing the DC power jack and put it into the beep mode, and let's see. Here's the beep mode here. So one pin I connect to the pin number 4 of this IC, and the second pin I'm going to connect. If you look at it, I'm just doing this right now, connecting here, and the other pin I'm connecting to the AC drive of these two MOSFETs. Where is the AC drive connecting to these two MOSFETs? Oh, here. This is the gate supply. So AC drive is the gate supply here. It should beep. Okay, so there is a good connection from that IC all the way here to this resistor. So AC drive is not generating 24 volts to switch this MOSFET on, and that's why we are not getting 19 volt from here to here. Well, there could be reasons like in this instance, if you think about it, the IC looks okay. IC is doing its job, is receiving all the voltages and is giving all the signals that the voltage is okay, the current is okay, and is saying the adapter is okay. So the IC is fine. Now there could be a possibility on these two MOSFETs here that is stopping that signal that is supposed to come, that 24 volt signal is coming towards these two MOSFETs. There is a possibility these MOSFETs are stopping that signal. So next thing I'm going to do is check these two MOSFETs, and well, to check these two MOSFETs I'm going to put this into the diode mode, my multimeter. I'm going to the okay, so basic fundamental to check these two MOSFET is in diode mode you should get reading on the multimeter at when you put the probes. So you should get the reading from one combination of pins. So for example, this is one combination, so I'm getting OL. That's okay. So I'm gonna swap them around and I'm gonna check again. So I'm getting some value. So this MOSFET is okay. Let's check again. So I don't get anything here, but when I swap the pins around, I get the voltage. Not voltage, sorry, the resistance of 480 ohms resistance. Okay. Similarly, I'm going to check the second MOSFET, which is this one, the red probe and the black probe now. Oh, this is short to ground. Okay, let's check the other way around. Well, this is short. This is, instead of giving me reading, it's like, if you think about it, this area of the MOSFET is ground. In the buck converter, this area, this side of the MOSFET is ground. What it's doing, when the voltage comes here, 19 volt comes here, through this capacitor, it connects to this. Instead of doing its job, which is just open when there is an excess current to pass, what this pass to ground, what this MOSFET is doing is passing all the current to ground. So if, let's say, if 19 volt was coming here, this is like all one ground. This is just ground. All this is ground. So, well, let's see what the gate is doing. Gate is also connected. So all this has become one ground. So think about it, the 19 volt coming from here to here, and then 19 volt is going right into the ground here. So our main suspect is this one now. Okay, let's see. Okay, this is M0930M. Let's see which MOSFET is this now. M0930M. 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 Okay, let me share my screen with you. Okay, what we are doing is this. Okay, we are looking for M0930M MOSFET. It's available at AliExpress, ChipPay. Okay, that's interesting. M0930M replacement. Okay, well, someone already has this problem before. Okay, the question asked is, what is the replacement for this? Okay, this bit is interesting. Okay, so these are all the replacement for this MOSFET. Okay, let's see what we have it in stock. I see stock. This is the list of my available ICs that I have in a store. So I'm going to check if I have any of these MOSFETs available. Okay, find here. Come on, it's too slow. Okay, find MOSFET FDMC 884. Find, don't find anything. Okay, look for this one. Copy. Find. I don't find anything. Okay, look for this one. Oh, I found something here. I have this IC in stock. So this IC is in the box number 003. Okay, I'll grab the box out. Let's see. So P0903BEA, and the codes are A5GND, A5GNC. Okay, let's see. I've got the box out, and let's see. Okay, can't be this one. So we are looking for some smaller ICs. That will be smaller IC. That's a smaller IC. Can't be this one. Okay, the rest is all big ICs. So let's check those two or three. A5GNC. That's what we are looking for. So which one is this now? J7FH. That's not our IC. Goes back in there. Okay, we have this one here. A5GNC. That's the one. Oh, it's always good to keep some ICs in stock. You can't see it properly, but I can see it. A5GNC. Yeah, that's the IC. Okay, let's get the IC out. That's a bit used one. Let's use a new one. Don't know about this IC. Okay, and that's the MOSFET. Okay, out of curiosity, I want to just check what this MOSFET is. A5GNC brown. Okay, we have okay, let's see, desktop, and what we were looking for is this IC. Okay, I'm going to put this into the Google search and let's see what this IC is. So we have a data sheet as well available for this, and it's a MOSFET. Okay, we know it's a MOSFET, and N-channel MOSFET. So that's an N-channel MOSFET. So 24 volt from AC drive. That makes sense because if there is 19 volt, then ground will receive 24 volt from AC drive of that IC, and it will make this run. This MOSFET will work then. Okay, what else? Okay, we have this information: 30 volt, and resistance is 10 volt or 48. Current. Okay, so we have this here. Okay, we have the compatible MOSFET, and let's see if we can. If you can just put these back in there. So compatible MOSFET is ready now, and we will check this. I don't want to damage this capacitor anymore. Okay, I will do a few more things. I will check this MOSFET also after I take it out from the board. If it is really faulty, if there is any other fault, then we have to go for that as well and look for some other faults. Okay, okay, this heat shield tape, I'm just put this here just to save it. Hot air station on, temperature 420 to remove this MOSFET. Okay, warm up the area around it. Okay, okay, let's see. Okay. Okay, let's remove this MOSFET. We had a customer, so I had to pause the video. Where is my... Okay, warm up the area again. Some flux. Okay. Again, we had a customer. Let's pause it for a second. Okay, let's... Okay, this MOSFET is removed. Okay, let's check this before I replace it. I wish I could just check it before I replace it one more time. So we knew that this MOSFET was showing shortage for... Okay, bead range. Yes, it is shorted. Short to ground. Okay, I'm gonna check on the board if it has caused any damage. Right there. No short to ground. No short to ground. The gate supply is not short to ground. So we have basically there is so many pins, but there is only 3 pins if you think about it. This is 1 pin, the second pin, this is the third pin. There is a source, drain and gate. So they are not short to ground. They are not short to ground. So we have problem with this MOSFET for sure. Okay, my replacement MOSFET is ready, which we checked it. Okay, let's warm it up. I want to put some solder before I put the MOSFET just to make things easier, you know. Warm up. This is a leaded solder. Very basic. This is very basic soldering iron. I'm using Baku 702L and I've been using it for quite a while now. It's been 2 years. I've been using this one. It does the job for me. I've made my mind up so many times to change it, you know. But then I think it's working. What's the point changing it? Just a little bit. Okay, along with the hot air station, I'm just going to refine it. Okay. more flux, and my MOSFET is here, and I know that these 4 pins will go on top, so just warm it a little bit. Okay. Just align it and push it. So I'm going to remove the excess of the solder. From there, like this. Just pull it down a little bit. So new MOSFET in, and let's do the diode mode testing for this new MOSFET before we do anything else. Okay, so it should give value at any one side. Okay, it's not showing short to ground, that's one thing. Open line, that's okay. One side. Swap the probes, and I get 482. Well, this is the resistance value of the diode that is in there. Okay, now let's check with the power. I'm inserting 19 volt and 5 amps into this board now, and I want to go to the bigger this one now. So move this, and let's see. Okay, let's check with the power in 19 volt. It's doing, oh wow, we have a fan span. So it worked. The laptop is working now, and it's taking all the amperes: 318, 277, 269. I think the job is done. This is a done job. Okay. I'm going to just zoom out to the, yes, it's working. Wa alaikum assalam. Okay, so yes, this laptop is powering on now, and is taking all the amperes. 401. The fan is spinning also. Looks like it's done. One more thing I'm going to check right now is if I get my 3 volts at battery points. So we checked them earlier, and there was no 3 volts always present at these battery points. So let's check them now. Oh yes, we have 3 volt, 3 volt. This is something else, so we should have here something. Open line, 3 volt, 3 volt, and so at 2 different pins we are getting 3 volts. So they are SD and SCL lines. They talk to the battery about how much and how much to current is required for the battery to charge. So as soon as you plug this in, there is always 3 volt present at these battery points. So that's another way of checking if the laptop is working. Right now it looks good. I'm gonna put into the housing and I'll check if it gives me the display and it works fine. Just going to remove it. Alright, it's supposed to sit in here. It goes on top. Okay. LCD connector in. LCD. Okay, what else we have? We have battery for this. This pin is for something. What's this for? Okay, I won't connect it for now. I'll just leave it. And I'm going to connect this keyboard. It has the power button in it. Okay. And I'm going to put the power in. 19 volt, 5 amps. Hit the power button. And it's on. I think it's on. Let's see. Come on. Come on. Yes. So that's good. How do you do that? So it's working. Thank you. It's working fine. It's good. The job is done. So this is good. This is working now. I'm very happy that this is fixed. The customer is going to be very happy with this as well. So thank you for watching, and if you have any suggestions, if you want to leave any comment, please leave, and subscribe to our channel. You will see more videos with more explanations in coming days. Thank you very much.